Good morning, good afternoon, or good evening. My name is Josh Bowling, and I'm pleased to be welcoming you to today's screencast on hardening SSH on a Linux instance with multi-factor authentication. In today's screencast, we'll begin with a discussion of what multi-factor authentication is. Then we'll talk about why we may want to use multi-factor authentication. Next, we'll take a look at one multi-factor authentication solution that's based around the YubiKey, and we'll conclude with a demonstration of implementing that YubiKey based multi-factor authentication solution to harden SSH on a Linux instance. So, what is multi-factor authentication? Put simply, multi-factor authentication requires the use of two or more independent factors of authentication to successfully authenticate against a system. Broadly, we can think about these factors as falling into two different categories: the knowledge factor and the physical factor. So, what's a knowledge factor? Well, a knowledge factor is something that a user knows. It may be a passcode that's obtained via an SMS text message, or maybe a mobile app. It could also be a PIN code or something else. A physical factor is something that a user has physical possession of. It could be a hardware dongle, maybe a debit card, or even something else. You notice that I specifically use the examples of a PIN code and a debit card. And the reason for this is because the most common example of multi-factor authentication in the real world is an ATM machine. When you go to use an ATM machine and you go to authenticate against the ATM machine, you're required to present both a PIN code and a debit card. If you're unable to present either of those, then you're unable to access your account. And the same is true if an attacker wanted to try to gain access to your bank account via an ATM machine. If they had, say for instance, only stolen your debit card and didn't have the PIN code, then your account would remain secure. Of course, in this case, in this example, the debit card is the physical factor of authentication, whereas the PIN code is the knowledge factor of authentication. Why would we want to use multi-factor authentication? Well, we would want to use multi-factor authentication to add an additional layer of security to our existing logins that take the form of a username and password combination. And the reason that we want to do this is because while passwords have been used for a very, very long time, they also suffer from a fundamental flaw. And that's that passwords, no matter how long and how secure, are vulnerable to a brute force attack. If a user uses a weak password that would consequently have a weak password hash, then an attacker isn't going to have to work very hard and isn't going to have to use a very long and involved brute force attack against that hash to be able to decrypt it and obtain the password. However, if a user is using a strong password that's composed of upper and lowercase letters, special characters, and numbers, then an attacker is going to have to run a much longer brute force attack against that password hash, and that brute force attack is also going to require much more computing horsepower and time to actually be able to decrypt that password hash successfully and then be able to use those credentials against any system that they may be used with. But the point that I'm trying to make here is that any password, no matter how long and how complex, remains vulnerable to a brute force attack. If an attacker has enough determination, time, and computing horsepower, they can and will eventually crack your password hash and then be able to grab the accompanying password or the resulting password from the hash and, like I said, log into any system that shares those credentials. So you can see that we have one problem with passwords, but another problem with a password is that users a lot of times use very insecure passwords, and we as system administrators, we can sort of help our users along with this by using tools like password policies to enforce a certain level of complexity, but sometimes even that doesn't yield a very secure password. And users using insecure passwords in an organization is one of the largest attack vectors that any system administrator is going to face. So we've talked a little bit about the problems with passwords. So let's talk now about how we can look at trying to mitigate these problems. So multi-factor authentication, as we've already said, is adding another factor of authentication to our existing logins. And this is typically going to take the form of a physical factor of authentication, because we already have an existing knowledge factor of authentication, which is our username and password combination that we as the user know. And we're just going to be adding in a second factor of authentication, which will be the physical factor, which could be your phone or perhaps another physical object like perhaps your mobile phone. So now that we've talked about the problems with passwords and we've talked about one way to perhaps mitigate those issues, let's relate these concepts to a real-world example. So Gmail. Gmail is a very, very popular consumer email service, and for a very long time they used the exact same authentication methods that many other websites did, usernames and passwords. Well, Google eventually started offering two-factor authentication, and that helped immeasurably in helping to secure Gmail accounts, because previously the workflow with just a username and password being required for a login was just that. You would go to gmail.com, you would enter in your username and password. If they were correct, then you were logged in straight away. Well, with multi-factor authentication, the workflow changed to you would go to gmail.com, you would enter your username and password, but then you would be challenged for an additional factor of authentication, and in Gmail's case, that additional factor of authentication took the form of a passcode that was either texted to you or could be retrieved through the Google Authenticator app on your iOS or Android device. So let's move on and talk a little bit about our multi-factor authentication solution based on the YubiKey. Before we talk about this solution as a whole, I want to focus on the YubiKey itself. As you can see, the YubiKey is about the size of a USB thumb drive, and it has a single button. That single button has a single purpose, and that's to generate an OTP or one-time password. That OTP is just that. It's only valid one time. So once it has been emitted from the YubiKey and validated somewhere, it's never useful as an authentication secret again. So if an attacker manages to grab that OTP output, then it's simply garbage data to them and it will never be useful. I think this is a good opportunity to talk about the different types of hardware tokens, because there are a couple. So we'll begin by talking about a connected token, because that's what a YubiKey is. And YubiKey is classified as a connected token because it can't function standalone. It has to be used with some software somewhere to be able to validate the OTPs that are being issued from the YubiKey. Conversely, we have disconnected tokens. An example of a disconnected token might be an RSA Secure ID dongle, or maybe a Battle.net authenticator if you're a World of Warcraft player. And these tokens are considered disconnected tokens because they themselves have everything on board on the device that they require to be able to generate an authentication secret. Typically, these disconnected tokens, they rely on time, so they use the TOTP protocol, or temporal one-time passcode, and they operate based around time of day to be able to typically generate a passcode. So we've talked about the different types of tokens, and we've talked about specifically the YubiKey. So now let's dive a little deeper into the YubiKey and how it's going to play a role in our multi-factor authentication solution. The YubiKey is a super versatile piece of hardware. And that's to say that it can be programmed in a few different ways. So we've talked about the straight up OTP generation, and that's simply plugging the device into your machine, pushing the button, and seeing the OTP be generated and then validated somewhere. But we also have challenge response mode, which is what we'll be using today, and there's also a static password mode that can be programmed into the YubiKey, and that's typically used only if you want a long secure password for a system and you don't want to have to remember it in any way, and you want it to be basically baked into a hardware device. So it's important to note that if you're using static passwords, and especially using a static password that's being issued from the YubiKey, then that's not multi-factor, because at that point the single factor of authentication, in this case the single physical factor of authentication, is the YubiKey, because it is both the physical and knowledge factors combined, since it knows the static password. So the YubiKey is going to be the hardware piece of our solution. It's going to be the physical factor of our solution. But what about the software piece of our solution? Well, the software piece of our solution is going to be the PAM Yubico module, and that's going to be what's going to handle all the validation of the OTPs that are generated by our YubiKey. But it's important to note that our solution is one of many that you can create when you're using a YubiKey, because we've talked about the different ways that YubiKey can be programmed, and if you're using it with the right software or the right service on the back end, then you can create a very robust, cost-effective multi-factor authentication solution. And I say cost-effective because the YubiKey standard, which is what we'll be working with today, is only $25. So we've already said that because of the versatility rather of the YubiKey, it can be used in many different types of multi-factor authentication solutions as the physical factor of authentication. But again, in our case, we're going to be using the YubiKey in challenge response mode, and we're going to be using it in combination with the PAM Yubico PAM module on an Amazon Linux AMI. So now let's jump over to a demonstration of using the YubiKey along with the PAM Yubico module to implement a second factor of authentication for the SSH server on an Amazon Linux AMI. So now we're in a terminal session, and we're going to actually begin looking at implementing the multi-factor authentication solution we've been talking about. So the first thing that we need to do is connect to the Amazon Linux AMI that has been set up for the purposes of this tutorial. But at this point, it's important to note that these steps aren't exclusive to just an Amazon Linux AMI. These steps can be used on any RHEL-like distribution, so any Red Hat Linux derivative. So CentOS or Scientific Linux, for example. The first thing that we're going to do is we're going to connect to the Amazon Linux AMI, and we're going to do that with SSH. So we're going to go ahead and say EC2 user at, and I'm simply going to paste in the public IP address of this instance. Go ahead and hit enter. Yes, we'll accept the host key, and the connection is established. It's important to talk about what actually happened here. So by default, Amazon Linux AMIs, or well specifically the Amazon machine image that's based off of Amazon Linux, uses SSH keys for authentication. I'm not going to dive too deep into what that actually means and what SSH key pairs are, because I have a separate video and a separate blog post that dives into SSH public key authentication. But suffice it to say, we were able to connect to this instance because we were able to provide the public half of a key pair that was created for this instance. The way that this relates to multi-factor authentication is that in this case we're using only a single factor of authentication, and that single factor of authentication in this case is a physical factor in the form of the private half of the SSH key pair. So you can see that if an attacker were to compromise our key pair and were to obtain our public key, then the attacker could then log into any machine that happened to have our public key write the other half of that key pair. So at this point, let me talk about the concept of encrypting your public key with a passphrase. So we said that if an attacker was to compromise our key pair, then the attacker could then connect to any machine that the public half of that key pair was on. So we want to prevent that, and one way that we can prevent that using only SSH keys is to encrypt our public key with the passphrase. And at that point, when you go to connect to an instance as we have here, for example, instead of simply passing that key through, validating the key, and then connecting you'll first be prompted for the passphrase that that private key is encrypted with. And you have to provide it before the system can decrypt the private key to be used for authentication. So in the event that an attacker was to compromise your key pair and obtain your private key, your key pair and consequently the systems using that key pair remain secure because the attacker doesn't have both the physical factor of the SSH key and the knowledge factor of the passphrase with which the private piece of the key pair is encrypted. So technically, that is multi-factor authentication because you have the physical factor and the knowledge factor, but of course we're going to be using a YubiKey today in combination with the public-private key pair that's set up out of the box on this Amazon Linux AMI. Now, before anyone leaves a comment and says, hey, practice what you preach, because you may have noticed that when I connected through to this instance that I wasn't prompted for that passphrase that I'm encouraging you guys to sign your keys with. That's because I have that authentication secret and that passphrase stored in keychain on OS X. So I don't have to actually enter that long random string every time that I want to connect to a machine that's using that key pair. That would become very cumbersome and very tiresome very quickly. So I'm allowing OS X to store that credential securely in keychain. So it's just a convenience thing. It is signed with a passphrase. So I am practicing what I'm preaching here. So we've talked about the connection process using just a single factor of authentication, and we had a little brief aside talking about SSH keys and how they relate to the process. So now we know what happens when we try to connect with only a key pair. So let's go ahead and let's dive into the fun piece of this, and let's actually start implementing this multi-factor authentication solution that we've talked about, and let's actually see how things change once we get the YubiKey piece and the UP factor up and running. The first thing that we're going to do is we're actually going to remove the pre-installed EPEL repository from this Amazon Linux image. The reason that we're doing that is because for whatever reason the PAM Yubico module that we're going to need for this solution to be functional, it doesn't seem to be present in the repository for whatever reason. So we're just going to go ahead and remove it, and we're not going to do it with just the standard rpm-e command to erase the package. What we're actually going to do is we're going to use a while loop to do this, and the reason that I'm doing this is because if we actually run an rpm qa for query all and then we grep for EPEL, you can see here that the most up-to-date version of the EPEL repository at the time of recording is 6.8.9. This may or may not be the case when you come along and you happen to be following this tutorial or you happen to be watching this video. So what we're going to do is we've come up with a command that's sort of version number agnostic, and it's going to remove any version of the repository that it happens to find. So what we're going to do first is we are going to, well, actually the first thing I want to do is I'm going to bring up the blog post, right, the written companion to this video, just because I will be copying and pasting some configuration lines and things during this demonstration just to avoid typos, because live troubleshooting during a presentation like this in a screencast is not fun for anyone, and it doesn't make for interesting viewing. So just to ensure that I don't typo anything, I am going to do some copying and pasting as I go. So the first thing that we're going to do is, like I said, we're going to remove the EPEL repository, and we're doing it with a version number agnostic command. So we're going to run rpm-qa grep EPEL just like we did the first time, but we're actually going to continue using the pipeline, and we're going to say while read, right? Because while you're reading some data from the pipeline, and we're going to go ahead and initialize a variable inside this while loop, and we're going to call it repository. So while read repository, you need to do something. So do sudo rpm-e for erase, and we're going to reference the variable that we've just created inside the loop, and then we're going to close the loop by saying done. So just make sure that's all right. Make sure that I haven't typoed anything. Everything looks good, so we'll run this. Okay, that appears to be successful, but just to make sure, let's run the pm query command again, look for EPEL. Well, it's not installed, so it was successfully uninstalled. So the next thing that we're going to do is we're going to install a more standard version of EPEL. So we're going to run rpm-u, capital U, VH, and let me explain the command line switches that we're using here. So -u is actually for update. Capital U is for update. But the way that RPM handles packages, if the target package is not installed, then it won't be updated, it will be installed. So we're also passing in V for verbose, which basically says, hey, show me what you're doing, and H for hash marks. And you'll see what that means in just a moment. So I'm actually going to copy and paste the URL where we're going to download this package from, because I don't want to type it in by hand. So there's that. Let's go ahead and hit enter, and it's going to take just a minute to go ahead and install. And you can see here the result of the H switch that we passed in, right, the hash marks. So these hash marks are intended to indicate progress, and the installation of a repository package via RPM is actually a very quick process, so they just sort of immediately went to 100%. Okay, so the next thing that we need to do is, well, we won't clear the screen because you guys can kind of use this as a running history of the commands that we've executed. So the next thing that we're going to do, we're actually going to look and just make sure that we now have the PAM Yubico module. So we're going to run a sudo yum search PAM _ Yubico. And now what it's doing is it's going through and it's updating repository information, just to make sure that it has the most up-to-date information before it searches the repositories. Okay, and you can see that now we do have the PAM Yubico module. So now that it's in the repository, we can actually install from the repository using our yum package manager. And we're going to do that, of course, with sudo yum install PAM Yubico. Yes, this is okay. And yes, we're okay with accepting the GPG key. So now that that's been installed, we're going to continue moving along. And the next thing that we need to do is we need to create a group to hold the users that we want to enforce multi-factor authentication against. So we're going to do that with sudo group add MFA. And we're just calling it MFA just because we want to keep things simple, and MFA, which stands for multi-factor authentication, just seems like a nice, simple, memorable name. Now it's important to note that SSH 6.2 or higher, it can match on either a group name or a username. And the reason that we're using a group name is because if we enforce multi-factor authentication against a certain group on our system, then if we have another user come along and we add them to our system, then all we have to do to enforce multi-factor authentication on them is to place them into the MFA group, and they will have the same multi-factor authentication restrictions placed on them as other users in that group. And that just makes future administration of this solution a lot easier, because you don't have to go in and edit a configuration file every time that you want to add a user to the multi-factor authentication solution. So now that we've created the group, the next thing that we need to do is we need to add a user to the group. Well, for the purposes of the demonstration, we're actually going to use the existing EC2 user account, but if you wanted to create a brand new user, you would simply issue the user add command. And actually, let's not do that, because I don't want to venture outside of the written companion when we're talking about the video piece of this. Or no, actually we can do this because I have included a little note about this in the written companion. So like I said, we're going to use the existing user account, but if we wanted to add one, we would simply use sudo user add, and we're going to add the user to a secondary group right out of the gate. So MFA, right, the MFA group we created above, and Bob for the username, because Bob's a good user. Okay, so now we can actually run an ID command on Bob. And you can see here that Bob is a member of, first, his own group, and then secondarily, he's a member of group 501 or the MFA group. But like I said, we're going to be using the user mod command in this case because we want to enforce multi-factor authentication against the EC2 user. So we're going to use user mod, and we're going to pass it in add group. That's what the AG commands are, what the AG switches are. And then we are going to say MFA for the group name and EC2-user for the username. Whoops, we need to run that with sudo. Okay, so that's now done. So the next thing that we need to do is go ahead and edit our SSH server configuration. So we're going to open the etc ssh sshd underscore config file with vim. And the first thing we're going to do is we're going to search for challenge. Because we've already said that we're going to be using challenge response authentication as part of this solution. So we're going to change that parameter to yes. And then we're going to jump down to the bottom of the file. And I'm going to copy and paste some configuration in here because, once again, I don't want to typo anything. So just copy and paste. Alright, so what's happening with these lines is that we're telling SSH that it needs to match on the group MFA that we created earlier, and then it needs to enforce some authentication methods on users inside that group in this order. First, it needs to enforce public key, then it needs to enforce keyboard interactive. Alright, so those are all the changes we need to make to the SSH file, the SSH server configuration file. So we'll exit out of this with a :WQ to write our changes and quit. So the next thing that we need to do is we need to go ahead and restart the SSH server just so it can pick up on the configuration changes that we just made. And we need to do that with sudo service sshd restart. Alright. So the next thing that you're going to need to do is you're going to need to go and you're going to need to obtain your own ubiCloud API credentials. Because we've talked about the notion that the YubiKey is a connected token, and any OTPs that are generated from it need to be validated somewhere. So in order to do that, and in our particular case, we're going to be validating our OTPs against the ubiCloud service. And in order to actually be able to successfully perform that validation, you have to be able to issue an API call. And to be able to do that, you have to have valid API credentials from ubiCloud in the form of a client ID and a secret key. So in order to figure out how to do that, check out the link to the written companion in the description of this video, and in that written description, in that written companion, I have a step-by-step explanation as to how to go and get your own ubiCloud credentials to be used with this solution. So the next thing that we're going to do is we're going to go ahead and start configuring the actual PAM authentication piece of this. So we're going to do that by creating a file in the pam.d directory, and it's going to be called ubi-auth. Okay, and I'm going to copy and paste in the content of this file. Okay. So in this file, you're going to need to make a couple of edits. You're going to need to edit the ID field and the key field. And you're going to need to replace the placeholders that are present in these fields with your own information. So I'm just going to go ahead and add in my credentials that I have obtained for the ubiCloud API. Okay, now that that's done, I'm going to go ahead and write my changes and quit out of the editor. And now we need to create the authentication file that was referenced in the UBAuth file that we just created. So we're going to create that in etc SSH YubiKey underscore mappings. Alright, and the syntax of this file is actually fairly simple. It's simply username colon public ID of your YubiKey. The public ID of the YubiKey, it's either the first 12 characters of any one-time password emitted, or it can be obtained at demo.yubico.com. So in our case, we only want to enforce YubiKey authentication on a single user. In our case, it's going to be EC2-user. And we need to go ahead and obtain the public ID for that user's YubiKey. So I'm actually going to do that via demo.yubico.com. Do that just real briefly. So once again, syntax of this file is very simple. It's going to be username colon followed by the public ID of the YubiKey assigned to that user. Alright, now if that's done, we're going to write and quit out of this file, and we're going to move right along. So this is actually the last step of the tutorial. So what we're going to do now is we're going to edit the PAM configuration file for the SSH server itself. So sudo vim etc pam.d and sshd. Okay, and we're simply going to add a line in here. And this is going to be auth, and it's going to be include, it's going to be auth include, and I'll mention why we're saying include in just a second, and it's going to be ub-auth. Okay, the reason that we're saying include this as an authentication source is because if we said that it was required, then no users could ever log in to this instance via SSH, regardless of whether they were included in the MFA group or not, because the SSH server and the PAM login and authentication system within Linux would be forcing every single user that was trying to log in via SSH to use a YubiKey, regardless of whether they had one assigned to them or not. So we definitely want to say include versus required. Okay, so that's done. Now we're going to go ahead and save our changes. So that's it, guys. That's all of the actual configuration that's required on this instance to successfully implement a YubiKey as a second factor of authentication. So let's go ahead and actually see this in action, right? And we'll go ahead and we'll just log out. Okay, and this time I am going to clear the screen just so we can really see this output. So you saw that before I simply logged in with this command, right? SSH-I to pass in identity, username at IP address. Okay, so that's actually not going to change. That part of our workflow doesn't need to change at all. So let's go ahead and just hit enter. Okay, so this is a key difference. You can see that instead of simply being authenticated right through after validation of the SSH key pair had occurred, we're actually being told, hey, you're authenticated, but only with partial success. And what that means is that one factor of authentication that we have set up has been successfully validated, in this case the public-private key pair, but then it fell through and it said, hey, I also need another factor of authentication for this user, and in this case it's going to be the YubiKey that's required. So I have the YubiKey plugged into my Mac here, so I'm going to go ahead and hit the button. Okay, and you see that we're logged in straight away. So what happened there is when I pushed the button on the YubiKey to emit that one-time password, then the OTP was emitted, passed through to standard input within the shell session, and then the SSH server and the PAM authentication subsystem and the PAM module, they all worked together to validate that OTP, and of course we need to throw the YubiCloud service into the mix there as well, right? They all worked together to validate that OTP. I don't want to get too deep into the deep nuts and bolts technical nitty gritty of how all this works, because we could talk about that for a very, very long time, and I don't want this screencast to run too long. So you saw that we have to present both a valid private key and a YubiKey. So in this case, we can consider the private SSH key to be our knowledge factor, because the key is signed with a passphrase that only we as the user know, and then the YubiKey is going to be the physical factor of authentication that we as the user have. So if we went and we tried to authenticate against this instance, and I actually want to show this. So if we went and wanted to authenticate against this instance, okay, let's say that we're an attacker, right? Let's switch roles. Let's say that we're an attacker and we have managed to obtain the private SSH key from a user, and we also have managed to obtain the passphrase that the key is signed with. Okay, well, we've got that, and we try to log in, and oh, hey, well, okay, that's valid, but I need a YubiKey for this user. Well, the attacker doesn't have the YubiKey, so they're not going to be able to log in, right? They have possession of one of your factors of authentication, but not the other. So let's actually see what happens. Okay, so we're an attacker, right? We're a bad guy. Oh man, you know, we might have been stopped by this YubiKey thing. Let's hit enter though and see what happens, okay? Oh, hey, password authentication. Okay, let me make a note of this. This is maybe a little bug here in this solution, if you want to call it that. If you're trying to log in and you don't have the YubiKey for that user, if you hit enter beyond that, it's going to pop up a password prompt. The only reason that I can think that this would be happening is because password authentication is also a form of keyboard interactive. So if you fail the authentication phase for the YubiKey, that SSH is going to fall back to the next form of keyboard interactive authentication, which in this case is password. So this sort of weakens the security of this solution, at least on the surface. Okay, when we're talking about SSH, there are ways to further harden SSH. One way to completely mitigate this password prompt as any type of a vector of attack is to simply disable password authentication on the SSH server. That's the easiest way to do it. You could also not set a password for the user that the multi-factor authentication solution is being used with. That is technically a solution, but I do not recommend that, because a whole litany of issues start popping up if you don't assign a password to a user, and then an attacker manages to pop the box. Then they can start escalating privileges, right? You know, and all kinds of problems come with privilege escalation attacks if you don't have a password for a user that's even remotely privileged on a machine. So please don't do that. For anyone that's curious as to why that actually works, or I guess more aptly doesn't work, right? Why providing no password for an account would work in terms of preventing access if you were allowing a password authentication against your system in the first place. The reason that works is because an absent password and an absent password hash are different from a null password and a null password hash. Okay, a null password is literally an empty value. So if it's an empty value, and you know, let's say for instance EC2 user had a null password set, okay, you just hit enter right here without providing anything. Oh well, it timed out. But if we do this and we don't have a YubiKey, and we also don't have a password for the user, but it happens to be set to an empty value, well, boom, you hit enter and it's going to accept that empty value as valid authentication, because it is, right? An empty value equals an empty value. So an absent password, right, nothing set, is literally nothing. So any input from standard input from the keyboard, it's never going to match. It's never going to be valid, right? So no one could ever log in with a password for that user because there is no password for that user. So, alright, so that's that, guys. I'm just going to hit Control C to break here, to break out of this. So that's that, guys. That's pretty much this screencast in a nutshell. That is implementing a YubiKey to secure SSH, or to, I like to use the phrase harden, or use the word harden SSH, just because SSH is secure by design. So we're simply hardening SSH, or making it more secure or more resistant to an attack. Okay, so that's all there is to hardening SSH on a Linux instance, at least a RHEL derivative instance. So yeah, guys, that's that. I hope that you've seen that implementing multi-factor authentication, at least in the case of the YubiKey, it doesn't have to be expensive, it doesn't have to be cost prohibitive, and it doesn't have to be difficult either from the implementation and the administration side, or from the user experience side. So guys, that's pretty much it. I hope you have enjoyed watching this video. If you have any problems with any steps in this tutorial, or any questions or comments or anything like that, then please leave me a comment, and I'll be happy to help you with any problems you might have, or definitely engage with you about any questions or comments or anything you might have. But please make sure that you direct any comments or questions or concerns to the comments that are on the blog post that functions as the written companion for this video, just because I want to keep the conversation around the content, so that if someone comes along in 2 or 3 years and wants to also follow this tutorial, and maybe they bump up against the same issue that you had, then they can take a look at the comment section and they can see that we've already solved that problem together, so people in the future can benefit from the work that we do today. So please, guys, definitely do that. Once again, my name is Josh Bowling. I hope that you have enjoyed this video. Thanks for watching, and have a great day.